So now in this circuit we have three resistors, R1, R2, R3. R1 is 60 ohm, R2 60 ohm, R3 30 ohm. The voltage we don't know that, and we know I3 is 6 amps. We need to find the total volts, V1, V2, V3, I0, I1 and I2. Let's see how to do it. In this part we have R3 and I3, so we can easily find out the voltage, which is going to be equal to R3 times I3. So we have 30 ohm times 60 amp, that's going to be 180 volts. Now since it's in parallel, based on Kirchhoff law, we know all these branches have to have the same voltage. So V0 equals to V1 equals to V2 equals to V3 equals to 180 volts. So we know all these things. Now we need to go one by one to find out what is going to be the I here and I here. I2 is going to be V2 divided by R2, which will be 180 divided by R2 is 16. That's going to be 3 amps. And I1 equals to 180 divided by 60, same thing, 3 amps. So 3 amps, 3 amps, and here 6 amps. 3 and 3 and 6. So we have 6 plus 3, 9. 9 plus 3, 12. So I0 is going to be 12. Let's find out the equivalent resistance. Equivalent resistance for parallel circuits is going to be calculated using this formula, which means that the inverse of equivalent resistor is going to be the summation of inverse of all the resistance. 1 over 60 plus 1 over 60 plus 1 over 30. That's going to be 60, 1 plus 1 plus 2, that's going to be 4 over 60. So RT will be 60 over 4, which is going to be 15 ohm. We can check the I0 here as well. So we know I0 equals to V0 divided by RT, which will be 180 divided by RT, which is 15. That's going to give me 12 amp, which is exactly the same as in here.